DeviceFLO makes IoT enterprise ready and allows moving beyond the pilot phase. Most pilot projects don't scale as the processes in the IoT ecosystem do not scale. This causes high cost of data and a failing business case. The promise of IoT cannot be met without developing the discipline of dealing with the hardware operations cost effectively. DeviceFLO offers an answer to that new challenge. The DeviceFLO platform is designed with the objective to create a central place for managing all IoT-related lifecycle processes, technology-agnostic and tailored to the specific environment a customer operates in. Where possible, we use ERP connectors to fully automate planning, and delivering metadata-rich data streams. We are 100% focused on driving out cost from IoT hardware operations. Today, we're demonstrating DeviceFLO in the end-to-end planning and installation process of a few sensors in a heating room. Monitoring energy efficiency of gas and oil heaters is a simple measure in improving energy efficiency in the housing industry, as often the configuration settings are suboptimal. The first sensor measures the inflow and outflow temperature in the heating cycle. The second sensor measures outdoor temperature and a third sensor measures the gas consumption. We will demonstrate every step in the planning and installation process. Before entering the house, the enterprise planner needs to do a detailed planning in DeviceFLO. After login, the dashboard gives an overview of the rollout planning. We'll be returning to this page regularly. The customer sites have been pre-entered, and we have 4 sensors in the warehouse. A complete list of available devices on the DeviceFLO platform and the vendor where they can be ordered is visible, listed by type. Each device has a datasheet and handbook available. Starting point in this demonstration is the 4 devices that we pre-ordered and are available for installation. These 4 devices are listed here as 4 orders with order quantity 1. Let's start by printing QR codes on the devices that will help identification during the installation process. We have integrated a label editor allowing for individual label configuration as well as a label printer. Labels can be configured by an enterprise operator and the actual printing can take place by a worker in the warehouse with limited access to the portal. Customer sites in the DeviceFLO platform can be edited at any time, adding information such as contact person and how to access to the location where devices need to be installed. When using the digital twin function, the operator can select from a portfolio of housing assets that can be uploaded and are used for planning the rollout. The enterprise planner defines the exact target location of the device inside the house by simply clicking on the digital twin, giving each unit in the house its own specific ERP reference and short name. We select the boiler room of the house. Sensor type and skill level is selected to complete the asset planning. For high voltage installations, specific installer certifications can be required, and we consider that in the planning process. Planned assets are listed and ready for task planning. Bulk planning can take place by uploading a CSV format that is defined in the DeviceFLO platform. The installation can now be scheduled, assigning an individual user or subcontractors and setting target date and IoT platform. Scheduled tasks are visible in the task view of the DeviceFLO platform as well as in the smartphone app of the user. The process is repeated until all assets are converted in tasks. Automation can take place for hundreds of assets to reduce the number of clicks for the planner. With all tasks being scheduled, we are ready for field deployment. We revisit the dashboard in the Enterprise portal where we see 20 scheduled tasks. Tasks are in categories unscheduled, scheduled, failed, completed and subcontractor tasks. As long as these tasks are not completed, they can be rescheduled and assigned to another user or platform. After login to the mobile app, task data is synchronized and made available offline to enable the user to work underground without mobile connectivity. The tasks are grouped per customer site. Selecting the customer site gives a more detailed view on the specific sensors that need to be installed. We will be adding a device list that need to be taken from the warehouse to execute all the assigned tasks. Instructions on how to enter the customer site and the details of local contact person is visible to the user, and a navigation function is built in. This saves time for the installer in accessing the site, having all information at hand. In addition, the installation app provides digital twin details, installation manuals, a datasheet, instructions and troubleshooting information for the installer. Once arrived at the customer site, we start with the installation of the gateway. The installation takes below 5 minutes. For optimal flexibility in choice of sensors, we recommend a multi-protocol gateway with WM-Bus and LoRaWAN. Once the gateway is installed, we start with the installation of the sensors. The first step is to scan the sensors using the app scanning function. With asset and sensor identified, we initiate the registration procedure on the chosen IoT platform and continue with physically installing the sensor. We attach the 2 temperature sensors to the heating pipes using a simple tie wrap. The total installation takes a few minutes and can be done by any caretaker without any special knowledge of heating systems. After attaching the temperature sensor, the sensor body is attached to the heating system as well. We then add comments and tar. Key a picture of the installed sensor, allowing the operator to verify the sensor is installed. With the back-end registration still being in progress, we continue with the installation of the next sensor. The next sensor we install is the outdoor temperature sensor, for which we follow the same installation procedure, starting with scanning the label before attaching the sensor to the grid. Again, the sensor is installed using a simple tie wrap. We have asked the distributor to pre-activate these sensors to make sure the gateway picks up the signal immediately. The last sensor we are installing today is the gas sensor, with the objective to measure the gas consumption in the boiler room. Together with the 2 other values we collect, adding the digital twin information where we have number of units and building surface, we get a good insight into the boiler performance. Again, the installation is plug and play and intuitive. The sensor comes pre-configured from the supplier and allows installation without any specific knowledge of gas meters or taking any specific safety measures around the installation. The installation procedure is similar as with the other 2 sensors we installed, and at the end of the installation the installer makes a picture. In this case, the picture actually serves a more important purpose. We will use this picture to read the meter and remove the need to send the caretaker to the site a second time. We'll show later in the task post-processing section of this movie how that can be done. After entering the completion remarks, the installer is finished. A visual signal, green light in the app indicates that the sensors have been installed successfully and the installer can proceed to the next job. Back in the main task view of the app, the completed tasks are ticked off and we can see what other tasks are open. In the control room, the operator can monitor the progress of the tasks and get an insight into the issues that have occurred during or after the installations. The dashboard gives that overview. The task credit below shows the number of remaining tasks the enterprise can execute within its plan. In active assets, the green bullet indicates that data is being received on a regular basis and no battery issues are being detected. On house level, the same green bullet shows an aggregated view on all the devices installed in that house. The same feedback we have seen in the app at the time of installation. DeviceFLO measures these values on a regular basis during the lifecycle of the devices. In completed tasks, we get confirmation that the device is installed and connected to the appropriate IoT platform, but also a visual proof that the devices have been installed correctly. The pictures give more detail and we can adjust the comments made by the installer, or as in this case, collect metering data that is visible and enter it in the comments section. The installation process starts and ends in the DeviceFLO portal, giving the operator central control over the hardware operations and maintenance. This concludes today's Boilerroom installation. Feel free to contact us for more information.